This is the next portion of packet number 5 I asked you guys to try. And the first portion of that was numbers 18 through 21. And for section 18 through 20, the direction says for each table below, determine if it's a power, exponential, or linear function. Then find the equation. So the easiest thing to check for if it's linear, and that's, to be linear, it would have to have a constant average rate of change. In fact, let me get me some scrap paper here so I can write on. Let's see here. Oh, here's some. All right, so for 18, if this was going to be linear, and we did average rate of change, I would do 144 minus 64, 2 minus 0, right? That would be 80 over 2, which is 40, right? Then I'll do the next one. 324 minus 144 over 4 minus 2. That's a 2 on the bottom. So, let's see here. This would be about 18, I believe. 180. So it would be 324 minus 144. Yep, 180 over 2. It's 90. These are not the same, so that means we can rule out linear. So 18 is not linear. So now I'm going to test for exponential. Exponential is when we're going to compare y values. Now notice these are all spaced 2 apart. That's important because you need them to be the same in order to do this. So I'll do 144 over 64, right? And if I do 144 divided by 64, I'm getting 2.25. Then do 324 over 144. Right? 2.25, right? This is promising. This is the test for exponential. Right? 729 over 324. I usually like to do 3 of them just to confirm it. Oh, look at that, 2.25. So since these are all the same, it's also 9 over 4 if you reduce the fractions. So because these have a constant proportion, it is an exponential function. So for 18 is exponential. Okay, and then we have to find the exponential function. So for 18, that means we're going to do y equals a b to the x. And that's when you compare, right? So if I can do, well, they gave us a 0 power, so that's the best. So watch what I'm going to do. 64 equals a b to the 0. Anything to the 0 power is just 1, so that means a is going to be 64. So y equals 64 b to the x. Then take the next one, which is 144 equals 64 b squared. I'm going to divide by 64. Okay, which was this one here, right? 144 over 64, which before I said is the same thing as 9 over 4. This is 9 over 4 equals b squared. Take the square root of both sides. B comes out to be 3 over 2. So notice this is f of x. So you should write f of x equals 64, 3 over 2 to the x. And that is the answer for 18. You have to have f of x equals in order to have a formula or an equation. Without this, I would have to take off points. All right. 19, all right, same question. I'm going to do the test for linear first. So let's do 17 minus 20 over 2 minus 0. That makes negative 3 over 2. Right. Then I'm going to try 14 minus 17 over 4 minus 2. That makes negative 3 over 2. Well, and finally, if I test the third one, just to confirm, what you know it, negative 3 over 2. So since the 3 average rated changes are the same, this is going to be linear for number 19. Okay. And to do a linear function, we're just going to do y equals mx plus b. All right, so the m is the slope, which is this guy. So y equals negative 3 over 2x plus b. Take a point. The easiest one is 0, 20, right? So 20 equals negative 3 over 2, 0 plus b. So b equals 20. So when I go to write my formula here, we've got g of x. G of x is equal to negative 3 over 2x plus 1. All right. Next one. Now, okay, do the average rate of change. It's not going to be linear, right? If you do that proportion thing to see if it's exponential, right? So let's clear this. So if I do 128 divided by 16, we get 8. 432 divided by 128. All right, so it's not exponential. So this last one's actually going to be power, because that's the only option left, right? And for number 20, if it's a power function, you're going to do y equals kx to the p. All right, so let's take a look at this now. I'm going to compare two of them that aren't 0. I'm not going to plug in 0 as my base because that makes everything 0. So the best 2 points to use are the 2 and the 16 and the 4 and the 128. So I'm going to do 128 compared to the 16 is k, 4 to the p over k, 2 to the p. So the k's cancel. And 128 divided by 16, I just had done it, that's 8. 4 divided by 2 is, so that's 2 to the p. So 2 to what power makes 8? That's 3. So y equals k x to the 3, right? Then take one of the points, like 2 and 16. We do 16 equals k 2 cubed. 16 equals 8k. So that means k equals 2. So the formula for this one is going to be h of x is equal to 2x cubed. So these are the three formulas that go with the exponential, the linear, and the power. All right, for number 21, what is the domain of this guy? The natural log of x minus 5 plus 3. So the easiest way to do this one is that let's think about what a log graph looks like. So for number 21, we have g of x is equal to the natural log of x minus 5 plus 3. So the parent function would be y equals the natural log of x. So let's talk about how we would graph that, right? If we had to graph that, what we're really going to graph is there's an e here, e to the x equals, or e to the y equals x, right? Base exponent number. Then we're going to do an xy chart, okay? And because the y is in the exponent, we're going to put our negative 1, 0, 1 in the y column. And this would make 1 over e. E to the 0 power is 1, e to the first power. So this is our parent function. And the asymptote, right, would be x equals 0 for a log. Now, let's talk about this guy, right? Now, for g of x, okay, we're going to add 5 to the x's. So it's 1 over e plus 5. 1 plus 5 makes 6, right? And then it would be e plus 5. And then we're going to add 3 to the y's. It's 2, 3, 4. Okay? And the new asymptote would be x equals 5 because we have to add 5 to the x. So if I were to sketch this, x equals 5, 1, 2, 3, 4, 5. So that means I have a vertical asymptote of 5, right? This is the point 6,3. So that would be here. E is almost 3, right? It's 2.7. So this is almost 8 and 4. So that's 6, 7, 8. So almost 8, it would be 4. And this is like 1/3. So 5 1/3 and 2. So guys, this is what the graph would look like. So if you can get the graph, it makes finding the domain now for the logs a little easier. What would the domain of this be? Well, We're not touching the 5, right? We're starting from the 5, but not quite reaching it, and then we're going towards positive infinity. So that is my domain for number 21. Okay, after that, I asked you guys to jump down to number 22, okay, this guy, and I said let's just focus on D and E for now. All right, 22 is f of x equals x squared minus 4x plus 3. Then we have g of x equals 2x plus 1. And h of x is this chart. And D, right, 22D wants us to find the average rate of change over the bracket 0, 2. So that just means I want us to find the average rate of change, which is slope, between the x values of 0 and 2. So that means I'm going to use the point 0, 2, and the other x value of 2, 5. So I'm going to do the average rate of change of those. Whoa, my pen's falling apart. Which is 5 minus 2 over 2 minus 0, which would be 3 over 2. Let's see here. Average rate of change between 0 and 2. What is the next one? The difference quotient. I'm a little distracted because my battery's about to die, so I'm going to hold on 1 second while I go find my cord so my laptop doesn't die while I'm going over it. Okay, I have returned, but I got to plug it in. Give me 2 seconds. I think I saved it. I did. Okay. All right, so let me just double check this last one, just because I was distracted. It was going to die on me in the middle of it. Find the average rate change for f of x from the interval x is 0, x is 2, and that's the point 0, 2, and the point 2, 5. Change in y over change in x. Yes. Okay, for that one. Now let's do E. The difference quotient for f of x is x plus 5. So this is just average rate of change, guys. That's what difference quotient is. So let's take a look at this. E. I'm going to make it right here, 22E. So if you notice, guys, the denominator is just h. So I'm just going to put an h there. F of x plus h means I want you to go to the f of x formula, which is this guy, and plug in x plus h wherever you see an x. So I'm going to do x plus h squared minus 4 times x plus h plus 3. So this whole bracket is f of x plus h. Now from that, I'm going to subtract away f of x. And f of x is x squared minus 4x plus 3. All right, so now what I have to do is distribute this out. So if I distribute this, that becomes x squared plus 2xh plus h squared, right? Then I'm going to distribute this 4, minus 4x minus 4h plus 3. So all of this is this guy. Then I'm going to do minus x squared plus 4x minus 3 all over h. Okay. Now, let's start cleaning this up, right? We've got, and if you do your average rate of change, something should go like negative x squared goes with x squared, negative 4x goes with positive 4x, positive 3 goes with this guy, and that leaves me with 2xh plus h squared minus 4h all over h. Now, what do all of them have in common? We all have an h, so I'm going to factor that out. And that cancels. So the answer here is 2x plus h minus 4. So I'm going to write that in here. So this guy, it should be 2x plus h minus 4. Oh, no, what I just realized I did in this one? It asked for f of x. I did h of x. So actually, if I redo this one real quick right on the paper, if I do f of x, see how to give it from 0 to 2? Plug 0 into this. So if I plug 0 into this formula, that makes 3. If I plug 2 into this formula, it makes 2 squared is 4. 4 minus 8 would be negative 4. Negative 4 plus 3 would be negative 1, right? Then if I did the average rate of change on this, it's negative 4 over 2, and that would actually make negative 2, all right? So I made a little boo-boo because I accidentally looked at the wrong place, but at least I got to review 2 things. If I asked for average rate of change from a table, and they gave us an interval, that's how you would do it. Put points there. If I asked for a formula, you plug in 0, you get the first number, 2, you get the second, and go from there. All right, so that was number 22. Then I asked you guys to do 23a. 23a says for this function, find the long-run behavior. Now, anytime I ask for long-run behavior, it means I want the horizontal asymptotes on the edges. So that means I want to know what's happening to x as we head towards positive infinity, right? So what's happening to the y? And what's happening to x as we head towards negative infinity? So anytime I ask for the long-run behavior, it means I want to know what's happening towards the infinities. All right, so I'm going to do it over here on the side. Right? Now, this is where we did our limits. The limit as x approaches positive infinity. Now, this is where we did the most powerful. What's the most powerful thing in the numerator? X squared. What's the most powerful thing in the denominator? Also x squared, which would make 1. So as we're headed towards positive infinity, right, y would equal 1. Or y, you could put even arrow 1, means we're approaching 1. And if we did this towards negative infinity, nothing would change. We're going to get the exact same thing. So you would say y would be approaching 1. So anytime it says long-run behavior, I want to know what's happening towards the infinities. And that's the most important thing. I know you can do the rest of these. It was just the terminology I wanted to make sure you understood. All right, next one, 24a. For this guy, find the long-run behavior. And then this says in limit form. So again, long-run behavior just means the 2 limits on either ends. It's like doing the horizontal asymptote. So let's try this. I want to do the limit as x approaches positive infinity. Now, notice this guy, right, doesn't have a denominator. If you want to, you could just always put it over 1, right? What's the most powerful thing in this numerator? Negative x cubed. What's the most powerful thing in this denominator? A 1, which is lame. So now, guys, if you plug big positive numbers into this, right? If I plugged positive 1,000,000 into this, what kind of answer would I get? This answer would come out to be negative infinity. Now, what if I did the limit as x approaches negative infinity of this guy? Well, the most powerful thing in the numerator, again, is negative x cubed. Most powerful thing in the denominator is 1. If I plug negative numbers into this, right, what happens when you cube a negative number? It stays negative. And then what's a negative times a negative make? Positive infinity. So this would be the long-run behavior in limit form, right? If I didn't tell you what form, you could just write as x approaches positive infinity, y approaches negative infinity. Whoa, okay. And then as x approaches negative infinity, y approaches positive infinity. So this is in limit form. This is in if I don't specify. You could do either. All right. Next, I had asked you guys to do number 26. 26 says m of x equals 3x plus 5, and then x minus 2 squared. And I want to find the degree. Okay, so we want to do this whole thing out. Now this is a polynomial function, right? This is a poly. And the first thing I want to find is the degree. Now in factored form, the degree is what you get when you add all the exponents together. So that's to the first degree. The other parentheses squared. So the degree of this guy is 3. So that degree would be 3. Find the leading coefficient. All right, the leading coefficient would be what we get if we distributed all of this out. So let's take a look at that for a second. Some of you can probably just tell by looking at it, like I can kind of just glance at it, but the first parenthesis is 3x plus 5. X minus 2 squared means I would do x minus 2, right? Well, if you multiplied those two together first, you get x squared minus 4x plus 4. And then if you distributed this, you would get 3x cubed minus 12x squared plus 12x. And if you kept going, you'll realize that 3x cubed is your biggest power, right? Because that's our degree. And the leading coefficient is 3. All right. Now, x arrow infinity. This is the long run behavior, or the arms, right? This would be kind of like our arms. And what we can do here, if you guys want, we can actually make a quick sketch of this guy, right? 3x plus 5, right? If you set that equal to 0, we'd get negative 5/3, right? That means it would hit the x-axis at negative 5/3. This would hit the x-axis at positive 2. Okay? And if you wanted to get the y-intercept, if you plug 0 in for x, we get 5 times negative 2 squared. So my y-intercept would be polynomials, kind of like our arms. Or we can talk about it with the limit as well, because we know it's 3x cubed. And we're going to show how it all lines up. But, right, this is a positive graph. So that means this arm has to go up, right? We're going to bounce off him because it's to the second degree. Go through my y, and then we're going to go through him. Now, see how my arms are doing opposite things? That's because the degree is odd, right? So now, as I'm headed towards positive infinity, what's this arm doing? Going up towards positive infinity. This is my left arm, the long run behavior over here. We're going down to negative infinity. And is there any horizontal asymptotes in this? None, right? And any vertical asymptotes? None, because there's not a fraction, right? Now, could have also got the long run behavior by doing the limit of this. This is the most powerful thing. And if you plug in positive numbers, you get more positive numbers. So here's number 26. And finally, number 27. Whoa. Find the equation of lowest degree for this graph. All right, so this is a polynomial, just like we did. And I want the equation, so I'm going to write y equals a. It hits it at negative 2. So I'm going to put x plus 2. It goes through the point, so it's to the first degree. Then it hits the x-axis at positive 1. So it's x minus 1. Goes through it, so it's to the first degree. And then it bounces at positive 3. So I'm going to write x minus 3 squared. Then I'm going to take any other point I see, and this is the point 0, negative 24. So I'm going to do negative 24 equals a, 0 plus 2, 0 minus 1, 0 minus 3 squared. This is 2 times negative 1. That would be times 9, right? So I get negative 24 equals, that would be negative 18a. 5 by negative 18. This reduces, 6 goes into both, so 4 over 3 equals a. So the answer to this question would be y equals, and you do need the y equals, 4/3, or you can write f of x, it doesn't matter. And then you don't have to multiply this out, you could just leave it in factored form. x minus 1, x minus 3 squared. And that would be the answer to the question. All right. Now, again, you guys can do the other questions in this packet. They're all really, really good to practice. I'm going to post my answer key online to every question. Plus, these will be on there as well, done neatly. The more you practice, the better. But that is the second part of packet number